Okay, Bismillah ar-Rahman ar-Rahim. First of all, I would like to ask you all to be seated in your original seats because we want to organize the lab in a way that we have a fixed number of students at each bench. So can you please move now if you are not at your bench seated? Okay? Then, we are going to do one procedure of flasking for each bench. That means all 8 or 10 students sitting on that bench will be working with the supervising sitting in front, doing the procedure in front, okay? So that means we will produce one partial denture from each bench only, okay? So it's one partial denture from each bench. So you'll be joining the procedure together. We will also divide the steps amongst you. So for example, the first student will do something like sealing, the other will mixing plaster, the other will be placing the cast into the position. So you will be working under the close supervision of your supervisor for each group in the step that they are doing, and they will instruct you in detail what to do, okay? So the demo will follow as such that I'm going to say a step, okay? Show it to you quickly, and then you're going to perform it under close supervision with your supervisor, okay? So that is how we're going to work. So make sure you're staying with your supervisor. Try to be close to them when they speak about the procedure and follow the procedure, okay? So in a minute, we will begin the procedure. Okay, Assalamu alaikum. So the first step we're going to do for the procedure of flasking of a partial denture is the following. First of all, we want to make sure that the wax is bound to the cast firmly, okay? We want to make sure that the wax at all edges, there is no space. It's similar to the sealing step that we have done in dentures, but remember, why did we seal in dentures? Because we had a base plate. Here we don't have a base plate. We don't have that step, which we have a base plate. We immediately put the wax on the stone. So we just need to make sure that it's sealed all around the location, all around the teeth, and that it has a smooth and clear finish lines, okay? So that all of the lines are clearly in uniform thickness at all edges, okay? So this is correctly sealed. Then we need also to make sure that the clasps are still in location. Remember, some of you, while adding teeth, the clasps rotated. So they became touching the gingiva. So we don't want that, okay? So make sure that your clasps are in the correct location under the survey line, above the marginal gingiva, and we have a space between it and the marginal gingiva as around 1 to 2 millimeters, okay? So it's not touching the gingiva. Now also these wires can change in location while working, so we need to fix them by a drop of super glue. So you're going to go to the clasps and put a drop of super glue on them. This will make sure that the clasps stay in place while we're working with them. The third step is removing the teeth above the survey line in the areas that we have natural teeth. To understand it, you will see it later inside the flask. But the idea is that once we have drawn our survey line and we are above it by the wax, okay? We need these teeth to have no undercuts while flasking, because the flasking procedure, we want to make sure that the upper and lower flasks separate easily. So if there are any undercuts here, it will cause this flask to fracture, if the denture might fracture while deflasking. To make an easy removal from the upper and lower members, we do trimming by the following. We're going to bring our burr and trim over the survey line. So we're not going to touch the clasps, we're not going to touch the wax. It's all above, and it's inclined buccally. So the line we will produce is inclined buccally. To see it inside the flask, later on inside the flask we have a step where we need to separate the upper and lower flasks from each other during dewaxing. So we want all areas that were covered with teeth smooth on the upper member of the flask. Okay, so these are all smooth. How do we produce these? We had teeth there, okay? So how did we produce these? By cutting off the teeth, the natural teeth that were there, okay? So once we cut them off, what we will have in these areas smooth surfaces that can allow us to separate the denture easily when it becomes hard later on. So we cut them in an inclined form. So they are all inclined buccally. So the cut is inclined in this direction, okay? Buccally. So with the bear, you can notice the procedure. All natural teeth, I'm going to cut them away. And I'm inclining the bear buccally, okay? I began with the abutment to show you that I have not touched the wire in the procedure. I have not touched the wire. I also have not touched the wax lingually. So the wax morphology lingually is kept, okay? I just removed undercuts. So I continue. So notice that I have not touched the wax lingually, okay? So I continue with all the natural teeth on the anterior area, and I also do the natural teeth posteriorly. I don't touch the clasp, I don't touch the wax lingually, and this is the step you could begin now. So just to revise it, step number 1 is to make sure it's sealed all around. Cut the, fix your clasp, make sure your clasps are in correct position and put super glue on them. And then cut off the teeth, the natural teeth, over the cingulum. Inclined buccally. Can you please begin now? For this step, we have 10 minutes. The next step is identifying your flasks, okay? So you should have a flask suitable for the denture that you're going to use. So a flask will be composed of a lower lid, a lower member, an upper member, and an upper lid. Okay? So once we have identified our flask parts, we should all put Vaseline over all members. So this flask is Vaseline. All members are separated using Vaseline. This will help us later to separate the cast. Okay? The step after that, you're going to mix the plaster according to ratio, which is the water is 55 ml and the powder is 100 grams. Okay? We're going to mix according to ratio. And then we're going to put the plaster inside the lower member of the flask. And we're going to add in, using the vibrating table, we're going to put in the cast under vibration. I'm going to do it manually here, but you're going to do it with a vibrating table. We're going to insert the flask up to the point where we have the land area flat. So the land area is almost with the edges of the flask, okay? If I look at it laterally, the land area of this cast is almost with the edges of the lower member. Then we begin adding plaster, covering all parts of the cast except the wax. So we're going to begin like this. All parts that are not included in the wax up, we're going to cover them. We're going to add also plaster over the teeth that we cut. So the only thing that we will leave exposed from this flask once we finish is the wax area. So it will become like this. So plaster is added in between the cast and the land area and the rim of the flask, okay? It's continuous, it's smooth, the rims are clean. We have covered all the teeth, the natural teeth we have cut. It's embedding inside the wires. The wires are embedded inside the plaster. We don't see the wires through. We don't have any undercut around. Okay? We have exposed the wax fully. So if you look here, we have no undercuts. We have smooth, continuous surface between all bits and parts. And the wax is exposed to its full extent. So this is where you, in the bounded area, it's where you need to work a bit to expose the wax and clean all the wax. So the wax is totally clean. And all surfaces are smooth, from the cast, from the wax margin up to the rim. So here, from the wax margin up to the rim, it's smooth. Although you see some part of the cast showing, but it's smooth, okay? And the rim of the flask is all clean. These are the features we should get after we finish the first layer of a flasking. Okay, 5 to 10 minutes for this step, please. Now the next step that we're going to do, I'm going to first check the quality of the work. What we need to see is from the edge of the wax till the rim of the flask, there is a smooth surface. Okay? No undercuts. All wax is clean. All wires are totally embedded in plaster. The rim itself is clean because I'm going to fit the upper rim, so I don't need plaster between the upper and lower rims. I need to pay attention on the buckle, especially when I'm lowering the cast inside the flask. We told you that how much do I lower it inside the flask? I keep lowering until the margin of the cast is with the rim of the flask, okay? This is our criteria. So once this is located correctly, you will have this smooth surface between the bounded area and the rim. But if you insert it more, you will find that there is like a hole in here, okay, if you put the cast inside more into the flask. So what we need to see is a smooth margin. The teeth are all covered, no wires exposed. The wax is totally clean all around, okay? So this is this step finished. I had a question was, why do we need to cut the teeth before we add in the plaster? If we take a close look at this drawing, okay, suppose this is a tooth, okay, suppose this is a tooth, and you know that the tooth has the occlusal surface, you have the buccal undercut, and you have the wire. If I add plaster over this, okay, if I add plaster over this, I will have a very small margin of plaster, and I will have some edges that are thin. And these might fracture while I'm doing dewaxing or depacking or deflasking at the denture stage. So I don't want these small areas of plaster to fracture off because they are thin. They are like a flush, okay? Although the wire is embedded in this plaster, but we have thin margins for this plaster. And we have an undercut here. So we will have this plaster fracture during dewaxing. We don't want this. Instead, what we have is, once we put the tooth into plaster, before putting the tooth into plaster, we cut this off in a buccal inclination. So we will have a good layer of plaster over it, and it will be thick, okay? And it will withstand the pressure or the forces during dewaxing, okay? This is why we cut the teeth off. So, what's next? So what do we have here? Just to revise it, we have the lower member of the flask, we have the lid on, the lower member itself, the lower member of the flask. We have plaster, we have the cast, and we have the wax up of the denture. We place our next layer, which is the upper member of the flask. Don't confuse between upper member of the flask and upper and lower flasks. Any flask you work with has two halves, no matter we're working with the upper denture or lower denture, okay? So for an upper denture, we use an upper flask. For a lower denture, we use a lower flask. But in each flask, we have an upper member and lower member, okay? Just not to confuse terms. So this is the upper member of the flask there. Notice that because we have removed all plaster from the sides, we have good metal-to-metal contact, okay? Why do we need this metal-to-metal contact? Because at one stage, we're going to pack acryl under force, okay? If under force and using the press inside, you will have this space. If we have plaster, it will fracture off, okay? If we fracture this off, the dimensions of the denture thickness will be changed. So we don't want the thickness of the denture change or the location of the teeth move in relation to the ridge. Although it's 1 millimeter here, but that means 1 millimeter high inside the patient's mouth. The teeth are higher or lower by 1 millimeter, and this will cause problems, okay? So we have to make sure to maintain the dimensions of the denture as we have planned, that the metal-to-metal contact all around the flask areas at all sides, okay? So we want to make sure that this is fit. Once we make sure it's fit, then it's ready for the second layer of Vaseline. We put Vaseline all over the lower member with the rims, with the plaster, everything except the wax. Now we separate the lower, everything, all parts of the lower flask with Vaseline except the teeth and the wax. Okay, these we don't put any Vaseline on. We'll also put Vaseline on the upper member and then put it into location. Okay, fix it into location. And then we're going to add the second layer, which is stone, regular stone, up to the level of the artificial teeth. We're not going to go to the full length. We're going to stop at the level of the teeth. We're going to use the vibrating table to mix this while we're adding the mix of the stone, because we want to make sure there are no bubbles. The vibration increases the flow of the plaster. It adapts to all surfaces around the teeth and the wax, and it will eliminate any bubbles in between the layers, okay? So we're at this step where we're adding the second layer of stone. We are going to use the vibrating table. We keep pouring in the stone until the teeth are almost with the level of the teeth. We stop adding, and then we re-expose the occlusal surface of the teeth if they are covered with some remnants of stone. So we want to expose the occlusal surface of the teeth totally. Now what do we see after this second layer is added? We will not see anything from the cast or the wax. We will only see the occlusal surfaces of teeth. Okay? So you may begin the step now. Now we're going to do the step afters. So we need to make sure that we need to have clean rims after this step. Once more, the rims are clean. We have to have the upper lid ready. It is wiped with Vaseline, and the holes, which are vent holes, called vent holes or escape holes, you'll see them how they work in a moment. These are patent and open. And we make sure that the lid fits into location, okay? So we're checking the upper lid before we begin our work. Once this is ready, we also check our upper member of the flask. We need to make sure that the occlusal surface of the teeth is not above the rim of the flask. If the teeth are above the rim of the flask, that means we did not sink in the denture enough, or the cast, the first step. We have to sink in the denture or the cast enough to make sure that the occlusal level of the level of the teeth occlusally is lower than the rim, so we don't have an interference. We also had added the stone, the first layer of stone, up to the level of the occlusal surface of teeth. We re-expose the acrylic denture teeth. We make sure that they are clean and clear through the stone, and we are going to add Also using the vibrating table once more to eliminate bubbles and to increase the adaptation of the added mix. We add a third layer. The third layer, we call it improved stone. The term improved stone was used in your first book when we were talking about denture, but actually what is it? It's a bit stronger from the stone layer itself. It's made out of dye stone and stone. It's a mixture of dye stone and stone, or purely dye stone. Okay? The function of this is once this layer opposes the teeth, between the teeth and the flask, once we are going to pack acrylic later on, you will see the packing of the acrylic step, we don't want the teeth moving into the layers. So this layer will prevent the movement of the teeth better, so it will resist packing forces better. It also has another function. While we are deflasking meaning I want to harvest the completed denture, when I'm doing the deflasking step, it also can resist the hammering, because I will take out the denture once it's solid by hammering it out. Okay, so it will also resist the hammering procedure, not transmitting it to the denture and teeth as well. So what we are going to do now in this step, once more, make sure that the rim is clear, the teeth are below the rim, the occlusal surfaces of teeth are exposed. We're going to do the improved mix of stone, and then using the vibrating table under vibration, pour in the stone, the third layer. Now the third layer we need to add is, we will add it above the level of the rim. We will add some excess material. And once we place the lid into place, you will find that once you squeeze this into place, we need this excess material to make sure we have fully filled in the flask, because any empty space in the flask, if under the packing pressure, will move, the layers will move. We don't want to have any movement between the layers and the metal member. So we overfill it by the improved mix under the vibrating table vibration. And once you put the cover on, you will see also the stone going out these vents. So the excess stone will be escaping from these holes away. So you will make sure that the amount of stone inside, the improved stone inside, is exactly the covering all the layers and all the empty spaces in the flask. You may begin doing this step now. Now you have finished the flasking procedure, and this is immediately after flasking. You can see that the excess material went out of the vents around, and this means that this flask is fully filled with the layers. Once you clean this, we get the flask with the whole flask closed, and inside we have the cast, the wax, the teeth, and the layers of plaster, stone, improved stone, all embedded in here. Now we need to eliminate the wax layer. We call it DEWAXING, when we want to eliminate the wax. So when this is set, we prefer more than 1.5 to 2 hours to make sure it's well set and it will not dissolve while we're using this hot water. We place it in the DEWAXING machine. So we place it first in the chamber inside. We're not going to run it because we want the sound clear on the video, the demo, but we put it inside here and we run a spray. So there will be a hot spray of water running over here for 10 minutes. The timer, the temperature is around 85 degrees when it runs, and then we operate it so it will spray the hot water over here for 10 minutes. Once this is soaked in the heat for 10 minutes, that means the layers of the wax inside are no longer solid. They are soft, and they allow us to open the flask. So if we come to the flask here and open it, we will find that the wax is molten, and we put it back into here to do the final wash of the flask. So hot water will be running through here, and then we begin washing the upper and lower members. This step will eliminate all wax from around the teeth and from the cast. Once we have finished the dewaxing step, you would find that you have the lower member and the upper member separated. In the lower member, no longer we have wax, but we have the cast and the clasps. In the upper member, we have the teeth embedded in the layers. So this is a dewaxed flask. We take it out, and while it's still warm, we dry it by air and then do a separation step. Now the dewaxing step is complete. We have the lower member with the cast, secondary cast, and the clasps inside. We have the upper member with teeth in place. It's still warm. While it's still warm, we need to do a separation layer because we're going to add acrylic and we don't want it sticking onto the stone and the plaster. We want it to separate easily. So we're going to add what we call a separating medium, or the most famous material is called Molseal, and it's actual part of an alginate. It's part of an alginate that sets when it comes in contact with the stone or plaster. It takes the calcium from the stone and plaster and sets. So we're going to add it from outside the bottle. We're not going to dip the brush into the main bottle because the brush, while in contact with stone and plaster, might pick up some calcium particles. So if these calcium particles go into the main container, it will set and gel altogether because of the presence of calcium. So we dispense it out into another small container, and with a brush we begin painting. For the lower member, we paint everything: the rims, the cast, the lower part of the cast, the plaster layer around. We make sure that we paint the separator very well, and usually it's done in 2 steps. So it's still warm. We have painted the first layer, and the warmth of the cast will accelerate even the reaction further, and it will set dry. And we're going to paint a second layer. Now for the upper, we take care when we are painting. We try not to dip it too much in the cold Molseal. We paint around only the layers of stone. We try to avoid putting any monomer onto the teeth. We pay good attention that we don't over soak it with the monomer so it will not run on the teeth. So we very carefully paint around the teeth, in between the teeth, but not actually on the teeth surface. Because remember, this is a separating medium, meaning that it will place a space between the acrylic and the other members. So if the new acrylic does not come in touch with the teeth directly, the teeth will fall off the denture later. They will not have been included into the chemical reaction, which is interpenetrating polymerization. So this is the first layer of the monomer, of the cold Molseal added. And we go back to the first one. We find that because of the warmth of the flask material, it sets solid, and then we paint the second layer. Now in our painting, we make sure it's not visually apparent, so we don't have pools of this material, because pools of this material will cause us to have space between the fitting surface and the acrylic. So we want to make sure that it doesn't pool into place. It's only a thin layer added all around. Now for those that did not do a post-dam beading step, we can come in and do a beading line. We see that the beading line here is clear. It's similar to the post-dam we have in dentures. So we want to make sure that we have a good beading line. If you have not done the step previously, this is the time to do it. And then over it we place our separating medium. Okay, so this is ready from this side. Second layer added, and we go to the second layer here. Once more, pay good attention that we don't touch the fitting surface of the teeth. And we will even further clean the teeth later on, before adding in the acrylic. Once the second layer is complete, we come in with a new brush, a clean brush, and if we have anything of the cold mold seal on the teeth, we take it off, and then we paint on the teeth monomer. It's the same monomer in the acrylic mix. The function of this monomer, it will partially dissolve the fitting surface of the teeth. This dissolution makes it soft and it will swell. So the new monomer, the new acryl, will begin its polymerization from within inside the teeth. So these are polymerization chains, the way that acrylic sets are by polymerization chains. And once we paint this with monomer, the monomer, unset monomer, will soak the surface and it will penetrate in between the previously set acrylic teeth, because these have been set at the manufacturer site. So the monomer will soak inside and penetrate, and then once the reaction begins of polymerization, it will begin from inside the teeth. So the polymerization will connect the acrylic dough with the teeth better, and this is an actual chemical interpenetrating network. This is the name of it. So it's a chemical set. So if we have cold mold seal on teeth will not bind to the acrylic. If we have monomer on the teeth, we will have the cross linking of the polymers beginning from inside the teeth, and they will bind very well to the new acrylic. So now with a new brush, I come in with a new brush, I soak it in the monomer after I made sure that the teeth have no cold mold seal on them, and then I begin dripping this monomer over the surface of the teeth multiple times, because I need them to really soak and penetrate into the acrylic. So even if this acrylic, you see it set, but the monomer has the ability to interpenetrate the set acryl and soak it, and it will begin reaction from inside the tooth out and help the adhesion of the teeth to the new acrylic. Okay, and once it's dry, we're ready to do the acrylic. Now we're ready to do the acrylic packing. So we have the monomer ready. We add in the powder according to the manufacturer recommendation in terms of amount. But in general, we keep adding powder until it no longer mixes, you no longer see the powder unsoaked. So if we look closely at the powder, when we are close, we keep adding bit by bit. See this last bit I added, it soaked itself, so it took the monomer. I keep adding in small bits to the surface, it soaked itself. When I find that the powder no longer soaks itself, it's slowly soaking, that means it's sufficient. Okay? See, look at this powder. It's slowly soaking. That means not taking a lot of monomer. This is when I stop adding powder. Now I can mix thoroughly. So, mix it thoroughly, making sure that all layers are incorporated. And then immediately we cover it, waiting for the setting stages of the material. We cover it with a glass slab. Why? Because we want to make sure that the monomer is not evaporating. The monomer is highly volatile. It evaporates easily, and you can have the smell of the monomer very clear when we are mixing cold cure acrylic. That means the surface of this acryl can lose, this mixture of acryl can lose the monomer, and if it loses such monomer, it is no longer soaked and it doesn't have the glassy appearance. It will become granular. This granular porosity is caused by the loss of monomer during the mixing stage. In all setting times or all working times, we should follow the manufacturer instructions. So the time we wait for the dough this mix to reach the dough stage, it's preferable that you do follow the instructions from the leaflet accompanying this material. I recheck my material. Now we could still see that it's in the stringy stage, so we have to wait a bit more. It's still in the stringy stage, but I want to demonstrate for you how the stringy stage appears. So if I separate the material, if I'm using my fingers to separate it, it occurs in strings. This is because the acrylic monomer had penetrated into the powder, but it did not penetrate still into the bulk of the powder. It's only on the surface. So this is why it's sticky, meaning that powder to powder, it's sticky with each other, while inside the powder it's still not dissolved. So this occurs, the stringy stage or sticky stage. It occurs describing this, what you see. It's when you separate it, it separates itself in strings. The reason is partial dissolution of the powder. In this case, the powder has not penetrated, the monomer had not penetrated into the center or the core of the powders yet, so it's in the stringy stage. When the monomer penetrates into the center of the powder, so we're going to go back and cover it. In the dough stage, the monomer had penetrated into the powder better, so the cohesion of the powder itself to the monomer and to the rest of the soaked powder particles become better. This is when we go to the dough stage, meaning that the cohesion of the material is better, so it will hold itself in the form of a dough. So the one in my hand, because of the warmth of my hand, it accelerated it a bit. But you can see now, I'm losing more of the stringy stage and I'm going more into the dough stage. Why? Because the cohesion is increasing between the soaked powder particles. So this is the dough stage. Okay, you can see that it's playable and I could press it very well. So now the cohesion is better. It's holding itself in one dough. Okay, so that we call this the dough stage. If we continue waiting on this, it will go into the rubber stage when it becomes more hard. So let us check our material. The warmth of my hand accelerated the reaction of what I have in between my fingers. Now we are at the end, almost at the end of the stringy stage, but notice that the amount of material going to the wax knife is less and it's coherent with each other. It's beginning to gather with each other. So we are in the beginning of the dough stage. Okay, I'm going to show you more of the stringy stage. We removed it at the end of the stringy stage, but see the strings? The strands of the acrylic, as if it's a spider web. So this is the end of the stringy stage. We're going into the dough stage. So we took it out for you to show you the strings even better. Okay, so these strings occur when the powder is partially dissolved and not yet totally soaked with the monomer. The monomer is still on the surface. So we gather our material with our wet hands or Vaseline soaked hands because we need to make sure that the material is not adherent to our fingers. And it's better even to be gloved fingers. We put it inside. We try to pack it in two halves. Half of the material we place it on the lower. In this half of the material, we try to make sure we're going under the wire. So I'm pressing under the wire first, and then I'm adding more material for the thickness. So I'm going around the wires and emphasizing the placement of acryl beneath the wire. So I'm seeing the acrylic going beneath the wire. Okay, so emphasizing the wires and then adding the bulk of material over it. I also have part of the material, we just added excess material just to show you the procedure. But on the other side, we also place the dough and we begin packing it around the teeth themselves. So you also see that using our fingers, we're going to press the acrylic in between the teeth. This will increase the flow of the material into the interdental papilla. Remember that we have interdental papilla. We have located the wax in a way we have interdental papilla. So to make sure that the acrylic goes in between the teeth, we further press on this side, and then we reverse everything, put the flask back together, and we call this the packing step. Okay, look at the acryl going out of the sides. The excess acryl is going out of the sides. Okay, this is packing. This is manual packing, but actually we don't suffice ourselves with this. We put it on the press. So we lower the upper part of the press. It's called a hydraulic press. So manually we put the screw of the upper member of the press. We keep squeezing it until no longer it rotates. The handle of it does not rotate as much as possible. And then we continue adding the pressure from the press itself. Once the valve is closed and we apply the pressure, we will find that the excess of acrylic is squeezing out of the margins. You can see the acrylic going through the margins of the rims. Okay? We keep pressing until we reach the point around 200 pascals. But revise the number in your book, the pressure, and according to the manufacturer instructions. We look at the flush, we call this a flush, the excess acrylic going out of the edges. We call it a flush. In this partial denture, we're not going to do trial pressure or trial packing. We're going to do it as once. Once we removed it, what are we looking for? We're looking that the metal meets the metal without any flush in between. Okay? So this is the packing using the hydraulic press. We will maintain this pressure. We will maintain this pressure for around 5 minutes, and then we will remove it and immediately turn it under pressure, but we're using another device called the frame or clamp. It's a metal frame that will contain 2 flasks if we're doing an upper and a lower flask, and we will rotate it using a handle from this opening, and this will press this down, and it will maintain the pressure of the acrylic during the curing period. So now, after removing from the hydraulic press, we place the 2 flasks in the metal frame or the clamp, and we begin manually rotating the upper member into place. Notice that this is going down. Notice that this is going down and it's pressing down, and this maintains the pressure on the 2 flasks while the curing is happening. We keep rotating it manually. We keep rotating it manually until we get no movement of the clamp. Okay, and this is ready. So it maintains the pressure during the curing, and this will maintain the acrylic while the expansion cycles of the curing cycle. You know that acrylic expands and contracts. So during the expansion and then later contraction during the polymerization stage, it maintains that the flask is closed under pressure. So the net result is the acrylic almost exactly in dimensions similar to what we need. So it doesn't allow for any excess expansion. And once the contraction begins of the polymerization, the excess pressure maintains that we have excess material inside that compensates for the shrinkage as well. So this is now ready to be placed in the curing machine. If you see this excess that we had from the packing procedure, it's now running into the rubbery stage, so it's good to show it to you. Okay? Notice that when I apply my finger pressure on this, it springs back. Okay? And also if I need to put it, so notice the springing back. Okay? It springs back. It goes back to its original shape. And also, if I want to squeeze it into place and let it go into the minor details of the denture or the interdental papilla, this will not flow easily as the dough did. Okay? And using the press, if I put it under pressure, okay, if I put the rubbery under this pressure, this hydraulic press, because it's very strong, and this rubber is resistant to the pressure, it rather than flowing, it will actually either fracture the cast or move the teeth away. So we don't place this acrylic in the rubbery stage in the packing procedure because it will produce changes in the dimensions or it will move teeth into the layers of the flask. Now that the flasks are ready for curing, we place it in this curing machine. We notice that the curing machine is like a water tank. It has controls for the temperature and the cycles, the time. So it controls the time and the temperature. I would like you to revise from your theory in dental material books what talks about the long and short cycles of acrylic. So we have different curing cycles of acrylic. But the idea is, according to the manufacturer instructions, we put the temperature of the water and we control the time we apply this temperature at, and we will find that this device can control that it has 2 heat cycles until the fully set material. Okay, so we put it on, and once the temperature of the water reaches the first minimal, this is the one, so it keeps heating the water until it reaches this stage. This is when we can open it. Okay, and it's hot enough, and we'll place the clamp inside with the flasks inside this water. So we're using the manufacturer instructions. I'm not going to talk about numbers because you're going to follow the manufacturer instructions and you're going to know yourself, are you doing it in a long cycle or short cycle. So we set the temperatures are set, for example, in this cycle, and we set the time. For example, for this cycle might be 3 hours, 5 hours, depending on the manufacturer instructions, and we leave it, and it will automatically do the cycle in a manner when the time finishes, the acrylic should be cured, and we call this the curing of the acrylic. It's heat curing of the acrylic. The function of heat curing the acrylic is to get an acrylic where more and more of the monomer goes into polymerization. So the monomer is not free. The residual monomer is less than 2%. So meaning most of the monomer went into the polymerization reaction. So once this finishes, we will do the deflasking step, and this will be the subject of our next lab. The curing cycle of the acrylic has finished, and we notice that the knobs of the time and the temperature are now to 0. These automatically happen because this machine runs automatically, and it will stop after the end of the cycle. So once the cycle is ended, we remove the flask from inside the curing machine. This flask is left to cool down in room temperature. It's better to cool it by this. We don't want unwanted contractions because of the cold water, because the water, if we cool it under running water that is cold, the surface might cool down while the center is still warm, and this will cause some internal stresses in the denture. So we leave it to cool down in room temperature. We have another one that has already been cooled down, and it's ready to be opened. So using the handle of the clamp, we open it, and because we have tightened it, we might use the hammer to release it. Once it's loose, we can just simply do it manually and loosen out the clamps. So the function of the clamp is to keep or maintain this pressure all during the curing cycle. This continuous pressure on the denture during the curing will compensate for the shrinkage that happens during the procedure. Okay. Now, because we had used the separator, these members should be going out easily. But please notice that the location where we had put the plaster knife, do you see this chamber? This is where a plaster knife should be put between the members. If we put the plaster knife in between the layers on the side, we will ruin the metal under the pressure or the hammering. So we want to make sure that we don't ruin the metal-to-metal contact on the other sides of the flask. So the flask is designed to have chambers. You have a chamber here to separate the lid, and you have a chamber here to separate the middle part, and you will see that we also have on the lower lid another place to separate it. Okay, so this is where we begin hammering. This hammering produces impact forces on the denture, and this is why we try to hammer in a controlled manner. So it's not severe hammering, it's controlled. We are trying to control our forces. Once the plaster knife is entered, we try to wedge it out by wedging, yes, like a lever action. And the plaster knife is designed also on the other end to have the metal exposed. As you see, the plaster knife is designed to have this part also exposed for the hammering. So that's why we prefer using the plaster knife, not the wax knife or any other knife for this purpose. Once we see part of the separation there, we begin wedging the plaster knife between the layers. We have some separation now. And you notice that the wedging of the plaster knife in between the layers and separating them becomes a bit easier. And now we can go between the other parts of the metal, wedging in between. Now this is a good opening where we have separated the casts at the junction between the plaster and the stone layer. So this separation happened in a good location between the layers, the middle layers, so between the plaster and the stone. The cast is not broken, it's intact, and we might use that for checking our margins during the procedure. So we will take out this cast, and we have the denture on the other side, and we have the wires embedded in it. Part of the teeth, abutment teeth, fractured off the cast. This is okay, and we have the stone intact. Now this is the critical stage where we may need to make sure that while hammering off this stone, this denture does not break. So this is why we need controlled forces. Some other times where we might get this situation where the flask separates. You had good Vaseline on the flask, so the flask totally separated, but this still at the junction in between is not separated. Here we need to wedge in between these two layers using the plaster knife and hammer in a controlled manner, trying to concentrate our forces on the plaster, not the stone, because this will fracture off the cast and we can see the separation between the layers easier because this is softer than this one. Okay, so we'll continue with our first separation. Okay, now we want to separate the cast from the plaster around. So it's better or easier to begin by separating the plaster from the flask itself, the lower member of the flask. So we hammer and we try to control the hammering over the lid area. There are some other types where the lid is simply just taken off. So this is an internal lid rather than a surface lid. So we have this now ready, and we try to hammer it off. Notice that we are concentrating on our knocking on the plaster itself. Try to concentrate the knocking on the plaster, not the other material, because it's softer, and we try to begin at the edges where we can separate it easier from the cast. Okay. This is why we use a plaster around the secondary cast, because it's softer and its impact strength is lower. So when we hammer, the probability that the plaster will break is higher than having the fracture of the cast. So we use the gypsum plaster type around the secondary cast because it has a lower impact strength and it will fracture rather than having the cast fracture. Okay, so we try to control our forces on the plaster by hitting on the edges more, So how do we control? Once more, by hitting the plaster on the edges around the cast. And at all times you found that the technician was holding the cast very firm in her hand while knocking on the edges. This will support the cast not to have it fracture. And as you can see, now we have the full cast with us. And this can help us judge our complete denture in terms of extensions, in terms of any need for finishing the edges, and this will help us in the procedure of the finishing of the denture. Now this is the upper part of the flask, and you can see that it has a wedge shape. So it's like a wedge shape. So it's narrow from here and wide from here. So to separate this from the metal, it's better to go to the narrow side and push it through the push the stone through the edges. So we try to hammer. Okay, loosen it like this, and then once it's separate, we turn it out like this. And if it's not separated yet, if it was still in there and the hammering was not sufficient, we try to hammer on the margins of the metal until the metal separates, because also once more the metal is more resistant to the knocking effect. Okay, so we remove the material. Now this is very important. Now we want to separate the denture and we don't want it to fracture. So we concentrate first on removing this side. We could also use another type of a player or a cutter where we cut off the plaster, or by the knocking effect. Now, notice that she's firmly holding the whole thing in her hand firmly. So the forces, when they come down, they only come down on the edges, not on the center of the denture. Okay. Okay, notice that it's separated well. No, notice the separation was very easy because we had a separator between these layers. And it's very good here to see the opposition of the teeth with the stone, because it fractured here at this line. So it's good to see this, how we have here the tooth opposed by the improved stone here. Okay. Once more on the edges. The denture, the whole denture is inside the hand of the technician. And because the impact strength, it's not the impact strength, actually acrylic has a very low impact strength, but because we are controlling our pressure and our knocking only on the stone side, and this stone has a vertical relation and it's already not that bounded to the second layer, so it's easier for it to fracture rather than fracturing the denture. So this is using controlled forces. Okay. Preferred to have the vertical forces because they separate it from the denture better. Okay, and because it's separated well from the acrylic using the cold mold seal, you find that it easily separates from the denture, and now we have the full RPD in our hands without any separation.